So on this page, I would actually try this entire exercise 2, pause the video, and then come back and we do the questions. That's how we would do it in class. So if you did this problem, you typed your numbers in L1 and L2. The regression you should get for part A is y equals 3.131 sine of 0.017 x minus 1.318 close parentheses plus 12.095. Okay, so I'll erase that one and to get to the next question. It says, what is the greatest number of daylight hours predicted by the model? So this is a maximum question. So I'm going to start from the midline and add the amplitude. So if I added those two values together, I would get 15.226 hours of daylight. Next one, based on the context of this problem, what should the period of the function be? So if we think about the cycle of hours of daylight over a year, considering that this variable is days, we would expect 365 here. It says use the regression to calculate the period of the function to the nearest day. So let's see what comes out when we do our formula 2 pi over b. So 2 pi over 0.017 ends up being 370 days. What reasons could account for the difference between the expected period of 365 days and the period of the data from the regression, 370 days? You could have a bunch of different answers here. You could talk about rounding, right? We rounded these values. You could talk about measurement error. This data was measured from some sort of study, and maybe they measured something kind of incorrectly. So there's a lot of different ways you could go about this. Really no right answer for that one. So let's move down to the last question. It says the average daily temperature T in degrees in Fairbanks, Alaska is given in the table. Time T is measured in months with T equals 0 representing January 1st. So this is the cycle of temperature throughout a year, but now we're talking about months. So you want to use this data, use a regression, sine regression to get an equation. So I'm kind of fine on this one. If you want to go in your calculator, you can. If not, our focus is kind of part B. You could just copy it down from me. So if I found this value, I would get that f of t equals 37.4 sine of 0.5t minus 1.7 plus 26.5. Now the next question says your family wants to visit Fairbanks, Alaska during a month where the average daily temperature is always over 40 degrees Fahrenheit. Using the regression, graphically determine the months your family could visit Fairbanks, Alaska. So in Y1, we're going to graph f of t, and then we want to know when it's over 40, so I'm going to graph a Y2 at 40. So I'm going to do the rest of this problem in the graphing calculator. So I'm going to start out and put my equation in y equals. I will first check and make sure that my mode is in radians, which it is. So typing that equation in, I get 37.4 sine of 0.5x minus 1.7 and then plus 26.5. Thinking about my window, I'm doing months throughout a year, so I'm going to use 0 to 12. Makes most sense for the word problem. I'm going to change my scale just to ones. Looking at my temperature fluctuation, the lowest numbers I see are around -10 in my table. The highest number I see is 62.5, so I'm going to go a little further than that. I'm going to put -20 to 70. Now, one thing I did forget to do, I'm going to go back to y equals, I didn't graph 40 in y2, so I'm going to put that in. Okay. Now I'm going to go to my graph button and I should see a decent temperature graph. Notice, remember, we use a sine regression. This looks more like negative cosine, but that's because it's shifted over. Remember, it shifts it to make the appropriate graph. So we're trying to find these two spots here. So I'm going to go to second calc intersect, number 5. I'm going to get a little closer because we don't really need the buttons. I'm going to move over to one of the values. Press enter 3 times. So my first intersection is 4.14, 40. We'll go to the second one. Arrow over. Remember, you can also use a guess and type in a guess to get over to the spot you want to do once you get there to the guess point, but we'll use this way. Okay, so the next value is 8.94, 40. So at this point, we'll use those values and go back to the notes. So I am having a little issue with getting the order with the videos and everything, so I just drew this graph on a blank sheet. This is the bottom of page 57. So we did our graph on our calculator. Here is my 40. I already set up scales, you'll see, to start out this video, so I just used what I used on my calculator. So here is the y equals 40. Our intersection points were 4.14, so that's probably around here. And 8.94 was our second one. So probably somewhere around here. And my graph starts down here, comes up through, and then it's going to come back down on this side. We don't really need more details because this is just a sketch, it's not on a grid, so I'm going to label my intersection points. So thinking about the question says, during what months is it completely above 40? So we see in this 4th month, it's not always above 40. So if you think of the 4th month, that's April. In May, it's above 40. In June and July. Moving forward into August, we have to consider if we're going to include August. Basically between 8 and 9 is August, so we're almost with all of August above 40, but not quite because this is at 8.94. So we're just going to say these 3 months, the 5th, 6th, and 7th month are the 3 months when they can visit. One more thing we should have done is labeled f of t, so just make sure you're showing this is the y equals 40 and that's f of t.